How many permutations of the word square have none of the vowels together? We're trying to keep U, A, and E separate. If you haven't had a think about this problem already, pause the video now and have a go at solving it. Okay, so let's think about how we could solve this. So we'll have a look at it in a couple of ways. The first way is a little bit of a brute forcey way, thinking about all the different options that could happen. Let's think about our vowels. Our vowels, there are 3 of them. So what that means is there has to be 3 factorial permutations of the vowels, because they could be in any order of those 3. Now let's think about the consonants. Where could the consonants go? Well, maybe they go here, here, and here. So we also have 3 factorial permutations of the consonants of S, Q, and R. But there's something else going on here, because that's not the only way we could have done this to split them up. We have our vowels again. We could have had that. Well, there's actually some more options. We could have had that. Or indeed, put all my vowels in first. We could have also had 2 consonants there and 1 there. That would have kept the vowels all separate. So there's another part to this. There are 4 options for how we split. So in total, we have 3 factorial times 3 factorial times 4, which is 144. Now the second approach, the first 2 bits are exactly the same. We still have 3 factorial permutations for the vowels. And we still have 3 factorial permutations for the consonants. But now we're going to think about it in a different way. Let's this time think about putting our consonants in. So let's color code it again. My consonants go in 3 places. Now, what's the deal with where I can put the vowels? Well, in this case, I have 1, 2, 3, 4 places I could put the vowels. And I need to put in 3 vowels. So I need to choose 3 of these gaps. If I choose any 3 of these gaps, then the vowels are going to be separated. So I'm also going to have here and 4 gaps, and I need to choose 3 of them. For the vowels. So I get 3 factorial times 3 factorial times 4 choose 3. Now 4 choose 3 is equal to 4, so I'm going to get the same answer as I did there. So you can go through this sort of systematic listing of all the different options, and sometimes you have to do that. Sometimes you don't have this shorter route. In some exam questions, your only option is to go through some of the different possible ways of arranging things and then think about the permutations within that. But sometimes, if you're just trying to keep things apart, then you can get away with this. Find the number of gaps and how many of those gaps you need to choose to place the things that need to be kept apart.